Welcome to our YouTube channel, Math with Jeeva. This is our third video with the lesson Area and Perimeter. In the video number 1, we discuss about how to find the area of a rectangle and a square. Video number 2, we discuss about how to find the area of triangles and perimeter of triangles. In this video, today I am going to talk about parallelograms and trapeziums. Children, before talking about parallelograms, tell me, what do you know about quadrilateral? So far we have discussed about two quadrilaterals. What are they? Quadrilateral means you have four sides, right? And we talk about two quadrilaterals, but they have their own features which we can identify them separately even though they have four sides. Think about a rectangle and a square. Both of them have four sides, but we can, when looking at them, we can identify this is a rectangle, this is a square. Likewise, parallelogram is also a quadrilateral having its own features. Looking at that, specifically we can say this is a parallelogram. So how we can identify a parallelogram? So far we have talked about rectangles and squares. You know how to find a rectangle and a square, and how to find the area and perimeter of a rectangle and a square. So today we learn about parallelograms. It's again a quadrilateral having four sides, but what are the special features we can see in parallelograms? When you hear the term parallelogram, right, they are talking about something parallel, right? Look at this diagram first of all. So if you have learned this earlier, now when I draw this, you may say, that's the parallelogram. No, this is not a parallelogram. This is a quadrilateral. To me, okay, now I can name this as a parallelogram. Now tell me, what are the features we can see? The opposite sides are parallel to each other. That's what I use these arrows. I want to show these opposite sides are parallel to each other and these two sides are parallel to each other. And what is another feature I can see? These opposite sides are equal in length, right? So what are the main features we can see in a parallelogram? Opposite sides are parallel to each other and opposite sides are equal in length, right? So now we know how to identify a parallelogram. Now let's learn how to find the area of a parallelogram. The formula for that is base times or else base into perpendicular height. Perpendicular height, right? Now in video number 2, I talk about base and perpendicular height in a triangle. How to find the base and perpendicular height, and that perpendicular height should be drawn against the particular base. So we talk about how to find them. So here in parallelograms also, what is the formula? Area equals base into perpendicular height. Now children, I am going to mark this A, B, C, D, right? Again, there are four sides. Can you remember in triangles I told you there are three sides. Out of these three sides, one of the side can be base. But we want to be mindful to select the correct perpendicular height which is relevant for that particular base we have selected. So like in triangles, in parallelograms also there are four sides. One of the sides can be a base, but again we should be mindful to identify the correct perpendicular height. Right. So let's say I am going to select this CD as my base. Right. So then perpendicular height, yes, it's like this. Right. I can see this right angle here. So this is the perpendicular height. Let's say I am going to name it as H. And how do you find the area? It is base, it is CD times H. That is how you want to find the area of this parallelogram. Children, looking at this figure and tell me this H, can you name this in another term? So as these two lines are parallel to each other, can you see something? So when two lines are parallel to each other, so I measure the distance between these two lines. Here, let's say 10 centimeters. If these two lines are parallel, so the distance between these two lines here also should be what? 10 centimeters. Right. If so, tell me these two lines are parallel to each other and this perpendicular height, in other terms, the distance between these two opposite sides. Right? Okay. So then, now I don't want to take CD as my base. Now I am going to take BD as my base. Before that, earlier I took CD as my base and perpendicular height. Yes. Let's say they have not given in the question the CD value. Instead, they have given this is 10 centimeters. Let's say this is 8 centimeters. But the base I want to have this. You may think I have selected CD and they have given this H, let's say 7 centimeters. So they have given perpendicular height and I want to take this CD as the base. Now only information they have given AB and BD. So how can I find CD? Tell me. If you listen to me well, I told you when I was starting this, in a parallelogram, opposite sides are parallel to each other and also opposite sides are equal in length. Let's say they have given AB as 10 centimeters, then this CD also should be 10 centimeters. Right. Then let's say I am going to take BD as my base. If so, can I use this H or 7 centimeters as the perpendicular height? No. Why? Because this perpendicular height has drawn against this CD, right? So it is relevant for these two sides. So I can't use this H or 7 centimeters if I am going to take BD as the base value. If so, tell me what is the perpendicular height I want to select. That means the distance between these two opposite lines, so opposite sides, should be the perpendicular height. Why I use like that? Distance between two opposite sides, because I know as these two sides are parallel to each other, the distance between them is the perpendicular height. Right. So if I am going to select BD, so I should have a perpendicular height it's like this, right? So I should have perpendicular height which is drawn against this BD, right? Now I am going to give you another example. Now look at this. Yesterday we discussed with triangles also the same thing. Look at this. Okay. Now I have extended CD line and what I have done, I have drawn my perpendicular height here, right? Like in the previous video, the same example. Now tell me that this is H. Now what is the formula to find the parallelogram area of a parallelogram? Base into perpendicular height. So perpendicular height, yes, I can take this, look at this, the same distance, because what I did, I extended this line. So this CE line also parallel to AB? If so, the same height I can have everywhere, right? So the same height I can have everywhere. The height is same. Now tell me, what is the base value you are going to take? Again, I'll give you three options like in the previous video. Either CD, DE or CE. Can you remember? So this DE, can we consider? No, because it is not a part of this parallelogram. It is an imaginary line only. So I can't take DE, it is out. If I can't take DE, can I take CE? No, because CE is what? CD plus DE. If I can't take DE, so I can't take CE also, then the correct base should be CD for this perpendicular height. So you can see the perpendicular height. Sometimes inside the parallelogram, sometimes outside. What is the most important thing you want to think? Whether this particular perpendicular height has drawn against this parallelogram and what is the correct base side, or what is the side we can consider as the base, right? So now it's about area of a parallelogram. Now tell me, perimeter of a parallelogram? The same way, now we know the definition of perimeter. It is the distance of outer boundaries. If so, what you want to do? You want to add them. So let's say this is 10 centimeters for an example. This is 10 centimeters. And if so, this one also 10 centimeters. And here, let's say it is 8 centimeters. Here also it is 8 centimeters. Then what happened? 10 centimeter plus 8 centimeters plus 10 centimeters plus 8 centimeters. You add all the sides together to have perimeter of a parallelogram. Right. And when you talk about units, now we know. When we are talking about units of area, it can be squared millimeters, squared centimeters, squared meters and squared kilometers depending on the units we have used for each cell. And units of perimeter, it can be either millimeters, centimeters, meters or kilometers. Again, depending on the side we have in these sides. Right? Okay. Depending on the units we have used. Right. So that is about parallelograms. Parallelogram is a quadrilateral having four sides, and like rectangles and squares, parallelograms also, they have their own features. We discuss about them. Then we'll move to our next shape, trapezium. So look at this. Again, it's a quadrilateral. Now look at this. I'm going to draw it. Okay. Now look at this. This is a trapezium. What is the special feature you can see? Here, these two sides are parallel to each other. So, are these lines parallel to each other? No, they have not shown like that. Looking at this, we can see it is not. Right? These two lines are parallel to each other. That means the distance between these two sides should be equal everywhere. Right? To find the area of trapezium, what is the formula? It's a little bit longer. You want to remind it. So, remember it carefully. Half into, right, sum of the parallel lines, sum of the parallel sides times distance between them. What does this mean? We'll practice it with an example. Distance between them. Okay. Again, I repeat. What is the formula, children? Half times sum of the parallel sides times distance between them. Let's say, so now I am going to draw. So let's say this is 5 centimeters and this is 10 centimeters. And here Let's say this is 6 centimeters. Now tell me, how do you find the area of this trapezium? So I do it here. Half times sum of the parallel side. One side is 5 centimeters plus the other side is 10 centimeters. Sum or the total. Sum of the parallel lines. 5 centimeter plus 10 centimeter. Then times distance between them. Them refers to what, children? The parallel lines, right? Between them. So that means it is 6 centimeters. What can I do? Half times 5 times 10. It is 15 times 6. So rather multiply. So without multiplying 15 times 6, can I do something? Can I simplify this? Yes. Now I can simplify. How? 2 times 1, 2 times 3. Then it's easy for me. 3 times 1, 3. 3 times 15, it is 45. 45 what? 45 squared centimeters. This is the final answer, right? So we talk about how to find the area of a trapezium. The formula for that is half times sum of the parallel lines times distance between them. Half times sum of the parallel sides times distance between them. So how do you take the sum of the parallel side? 5 centimeters. So these are the parallel sides. And how do you take the sum? 5 plus 10. And distance between them. Them refers to what, children? These parallel lines. So this is about the area of a trapezium. Again, how to find the perimeter of a trapezium? Very simple. You want to add. So if you know the length of these two sides also, you add all them together to get the perimeter value. Because it is the distance around the boundaries. Right. So today we discuss about the area and perimeter of a parallelogram and trapezium. So this is our third video. Next video, before moving to circles, area of a circle, perimeter of a circle, we are going to talk about few compound figures, how to find the area of a compound figure, how to find the perimeter of a compound figure. So it's our next video. So hope everybody understood today's lesson. If you feel you understood this lesson, and if I watch these videos or else the series of these videos, I can learn maths concept well. So subscribe our YouTube channel Math with Jiva and click the bell button to get the notifications in future. So till we meet again with compound figures, see you children. Have a nice day.